Well, we all know that the 2G is going to stop working in near future, and well, it already stopped working in a couple of countries. So I'm trying to learn and teach you all about using different 4G boards so that we all can continue our IoT journey in future as well. So with that respect, I already uploaded a video about a 4G board which was from MakerFabs, and now in this video I'm gonna teach you, or rather make you aware about a new 4G board from Lilygo. So this is the T-SIM7000G board, which is nothing but an ESP32 based board along with the 4G and GPS connectivity built in, and not only that, it got a lot of other features as well. So in this video I'll let you know everything about this board, like its specifications, how to use it with Arduino ID for all those basic tasks like sending and receiving SMS, getting GPS coordinates, connecting it with the new Blynk Cloud server, making it act like an MQTT client board to make it communicate with the Adafruit MQTT server, and a lot other examples. So this will be the one and the only video which you need to watch to get completely familiar about this board from Lilygo. So just sit back with your snacks and enjoy this video. Let's get started. Do you know what most electronic companies have something in common? Well, it's the tool that they use for making their products, and the most commonly used tool that almost all the big electronic companies uses is the LTE-M PCB designer software. Using LTE-M, you can definitely level up your PCB designing skills and make something really professional out of it. And now, along with the integration of Octopart, searching for any electronic components globally becomes really very easy. Octopart is kind of Google for just electronic components, where you can search for any electronic parts and get that information all on one single web page. So do check out this amazing search engine made just for electronic components. I'll leave the link for this down in the description. Do check it out. So this is how you will receive this product. Well, I'll leave its purchase link down in the description of this video. So inside the box, first of all, we get this main board about which we will talk in detail later in this video. Other than that, we get a full band LTE antenna, a GPS antenna, couple of mail headers, and a connector for solar panel. So this is all you get inside the box. Now let's have a look over the main board. So first of all, this board is based on ESP32 wrover E module, so you can expect the Wi-Fi and Bluetooth connectivity built in, and as it is of the series N16R8, it has onboard 16 MB of flash memory and 8 MB of PS RAM, so it has enough memory for all your complex and lengthy codes. Then the other major component on the board is the SIM7000G module from Simcom, which supports all different kind of bands like GSM, GPRS and LTE. But when I tried connecting a SIM card whose network provider only supports the regular LTE, well, that SIM card was not supported on this board. And when I did a little bit of research about this board, then I found out that it supports only LTE-M, or you can say Cat-M, and NB-IOT connectivity bands under LTE or under 4G, okay? So make sure you do a research about, do your network provider provides the NB-IOT or LTE-M or Cat-M based connectivity or connectivity bands in your city, your location. If is it so, then you can consider this 4G model. Otherwise, you can use it for your 2G based connectivity like GSM and GPRS. Other than that, it also has GPS built in for all your location based projects. And as usual, we can interact with this module via AT commands, which will be provided here by our ESP32 module. Now here we can insert a nano SIM card on this slot. We do also have a micro SD card connector for storing data, a USB Type-C port to program the board and charge the battery. Then we have a 2-pin connector for connecting a solar panel with this board. So yeah, this board do come with a solar panel connector on the board, and not only that, it is also based on CN3065 IC, which is a solar energy charger IC. Then we also have a dedicated reset button and power button on the board, and couple of GPIO pins for our ESP32 module. On the back, we have a 18650 battery holder to make this board run on battery. So that was all about the specifications of the board. Now let's jump onto the computer, open up Arduino IDE, and let's see how to program this board for making different projects. Okay, so here is my Arduino IDE. Now the prerequisite before using this particular board is you need to have the ESP32 boards packages already installed on your system, and you need to have the TinyGSM library already installed. After that, what you need to do is you can go to the repository by Lilygo, and here is the repository, and here are a couple of example codes that will definitely help you to kickstart your IoT journey with the help of the SIM7000G module. Okay, so what you need to do is you just need to click on this code button and click on the download zip, which will completely download all the files. I already did that in my computer. So yeah, here is that particular zip file. I unzipped it, and here under the example section, as you can see, there are a lot of example for different purposes. Okay, well, but let's first start with a very basic one, for which we need to go to Arduino TinyGSM and into AT debug. I'll open this AT debug example code. Now what it will do is it will help us to interact with our SIM7000G board via AT commands that will manually typing inside the serial monitor. Okay, so yeah, this is the code about that particular module. Now here I'll change the baud rate to 9600, as my version of this board communicates at 9600 baud rate. Okay, rest of everything will be the same. Now as I said, you need to have the TinyGSM library installed, but for this particular example you don't need to have that library. So what I'll do is I'll select the right board, which is ESP32 dev module, which comes under the ESP32 Arduino section. Then selecting the right COM port, I will directly hit the upload button. Now before uploading the code, I already connected the VI SIM card with this module. Now here in Ahmedabad, Gujarat, we don't have any network provider that supports the NB-IOT or CAT-M or LTE-M connectivity. So I'm using this VI SIM card and I'll be using the GSM GPRS connectivity, or you can say the 2G connectivity on this particular module to show you the demo. But as I said in the beginning, if your network provider supports NB-IOT or LTE-M, you can go for the LTE version as well. So the code is successfully uploaded. I'll open the serial monitor and I'll click on the reset button on the board. It says starting up the modem. Okay, so now we are good to go to write the AT commands. I'll type AT. It says okay. That means we are successfully able to communicate with the SIM7000G module. Okay, let's try out a couple of AT commands and let's see how it works. Okay, so first of all, I'll type CPIN first of all, CPIN question mark. This will help us to check whether the SIM card is properly inserted or not. So it says ready, means it's completely working fine. Let's check if it is connected with the network. So which network it is connected. So I'll type COPS question mark, and as you can see, it is connected to VI India, that is Vodafone Idea India. That is the connectivity, and AT plus CSQ will let you know the network strength, you can say. Just a second, AT plus CSQ. Yeah, this is the network strength. Means it is successfully connected with the Vodafone Idea's network provider. It got the network strength as well. Now what we can do is, first of all, let me make you clear, this board won't help you to make or receive any calls. I don't know why, but this feature is not at all supported in SIM7000G. We can't make a call, we can't receive any call as well. That's a oopsie feature. Like we won't, like I was also not expecting this from this particular 4G model, but yeah, this is the truth. So now let's directly move on to receiving the SMS, how we can receive the SMS. But for that we need to do a couple of configurations. So first of all, you need to do is AT plus CMGF is equal to 1. This is the one thing you need to do. After that, you type AT plus CSMP is equal to 17,167,0,0. Press enter. Great. After the last command, AT plus CNMI is equal to 2,2,0,0,0. Yeah, so these three commands are mandatory to receive the SMS in a text format. Okay, so now we are ready to receive the SMS. So what I'll do, I'll send one SMS from my mobile phone, and let's just see if we are able to receive the SMS or not. I'll just type the message as hello from Sachin. Okay, I'll send that message. So it's sent from my side. Now let's just see. Okay, as you can see, we got the message though. So this is the mobile number from which we have sent the message. This is the date and time on which we received the message, and this is the actual message, which is hello from Sachin. So this is how we can successfully receive the SMS and do all the tasks like SMS based home automation or stuff like that. Anything you can do. Okay, now let's just see how to send the message, but I won't let you know with the AT commands. Rather, let's just see how to use the TinyGSM library, because by using TinyGSM library, you no longer need to remember any AT commands at all. Just do some, like, call some function, or rather call one single function to send any SMS. Let me show you that particular example code which I already written. So I'll quickly open that example code, which is this one. Don't worry, I'll providing this example code in my GitHub repository, whose link will be down in the description. Okay, so here you need to provide the target, like SMS target, the number on which you want to send the SMS. Then there are a couple of functions called to set up the modem, pretty common. And here, by just using one single function called as modem.send SMS, you can send any SMS that you want. You just need to type the payload of that SMS here. So right now I written as hello from techiesms, but let's just say subscribe now. Yeah, because that is something every YouTuber wants. Okay, so I'll upload this code, and this code will be sending the SMS subscribe now to this number. Okay, one single function to upload that command. That is the power of a library called as TinyGSM. In case you don't have that library, you can just go to Sketch, into Include Library, into Manage Library. Here just type out TinyGSM, press enter, and you just need to install this particular library. Great. So again, I will directly hit the upload button, as I already selected the right board and COM port. Yes, it is selected, so I'll straight away hit the upload button, and let's wait for the code to get uploaded. In the meantime, let me tell you, here I have set the baud rate as 9600. In case your GSM or the 4G module supports different baud rate, make sure you change the baud rate here. Okay, so it's done uploading. I'll open the serial monitor. I'll press the reset button on board. So it will be running some AT commands on the backend to make the modem initializing modem basically. And here is the phone with me. So right now the last message was hello from Sachin, which was sent from here. And subscribe now message is sent from the board. And here is the subscribe now message. Let me show you on the camera. So as you can see, this is the message called as subscribe now, which I received straight from the SIM7000G module via my VI SIM card. So this is how you can simply send the message by using one single function, thanks to TinyGSM library. Now moving on to the next part, which is let's just try to make some cloud-based project using this 7000G. So I already created an example code for making the communication with our Blynk server. So this is the example code. I'll open that example code quickly. Okay, now I made this code by taking the example code which was given in the GitHub repository as a reference. I have added my template ID, my device name, my authentication token, and I also added the APN name, which is www for VI India. In your case, you need to search for the APN name of your network provider. You will easily get it on Google and just paste that APN name here. Again, changing the baud rate to 9600, and here I made a simple code in which I'll be able to control the LED on the board via virtual pin V3, and also it will be sending some random data like H is 12.2 and T is 24.3. So this data it will be sending on to my Blynk. Let's just change this data to, let's just say 55.3, and this will be like 32.2. Okay, so this is how the data will be sent, and yeah, pretty much everything is like same, like initializing modem and everything. So what I'll do once again is I will select the right COM port and board, and I'll straight away hit the upload button. In the meantime, let's just open the blynk.cloud what we can say console. So I'll just go to blynk.cloud, and yeah, I'll go to this project. So currently this project is, as you can see, in offline state. So let's just wait for this code to get uploaded, and hopefully it will get connected to the Blynk Cloud. Make sure your SIM card do have the data plan as well to make it connect with the internet. I'll press the reset button on the board. Okay, it says fail. I'll reset once again. Okay, so I guess it is now connected with the Blynk Cloud. Let's just go to the Blynk Cloud, and yeah, it says online, and as you can see, we are also getting the data. This is 55 and this is 32, which we were sending from here. Let me just show you the data. As you can see, the 32 and 55 is sent from here, and let's just see if we are able to control the LED on board or not. So this is the SIM7000G board, and I'll turn on the relay 3. As you can see, the blue LED got turned on. This is the blue LED. I'll just turn it off. Okay, so as you can see, the LED is turned on and off based upon the Blynk Cloud server, and it is like it has a very low latency, so it's almost real time, you can say. So you can easily make any of your IoT projects connected with internet without any Wi-Fi connectivity at all using this module. You can easily make it with the Blynk version, a Blynk platform. And not only Blynk, you can also use the MQTT platform or MQTT broker for your IoT projects. I do have the example code for that as well. I'll quickly open that up. Well, I had tried to cover almost all the things that will help you to start your IoT journey using this board. Okay, so this is the example code in which I made the connections with the Adafruit IO broker, the Adafruit MQTT broker, and here also I'm trying to send the data and receive the data via MQTT, of course. Okay, so now here what changes you need to do is you need to provide the broker name here. After that, you need to provide the topic on which you want to publish the data and topic on which you want to subscribe, right? So this is both things we need to define here. After that, again, you need to change the baud rate according to your board. I'll change it to 9600 quickly, And after that, here I have provided the callback function as if I get the data 1, I want to turn on the LED. If I get the data 0, I want to turn off the LED. Okay, and the same status, like whatever the status of the LED is, it will be reflected onto another topic that will be have a look while we'll be looking at the working of the project. After that, here I have provided the username and password, which is nothing but my username of Adafruit IO, and this is the AIO key of my Adafruit IO account. Okay, in your case, you need to provide the username and password of your MQTT broker, a pretty common thing if you have used an MQTT broker before. Okay, and after that, what we are doing is like we are doing nothing much here. It is just like handling the GPS and GSM connectivity and the MQTT connectivity. Okay, so this is the example code which you can take as a reference for your MQTT based projects using the GSM connectivity. Once again, I'll hit the upload button, and in the meantime, I'll open my Adafruit dashboard. I'll open a new window and I'll type the credentials io.adafruit.com. Once again, you can use any of the MQTT broker of your choice. So yeah, here it is. I'll go to the dashboard and I'll click on the welcome dashboard. And this is a random dashboard which I have created, but yeah, I have used the relay 1 button to control the LED. Let's just wait for the code to get uploaded. Okay, it's done uploading. I'll open the serial monitor. I'll press the reset button once. Okay, initializing modem. Okay, it says network connected and GPR is connected. It is not connected with MQTT, but yeah, connecting to io.adafruit.com. It shows success here. So I hope it is successfully connected with my Adafruit MQTT broker. Let me just take you to that dashboard, and if I turn on the relay 1 switch, the blue LED should get turned on. Let's just see. Okay, so it's in a reverse logic. So when I turn it on, it's turning off, and when I turn it off, it will turn on. So as you can see, this is the blue LED turned on right now, and this is how it got turned off as well. And similarly, I'm able to see the data here, which is published by the SIM7000G. So if I turn it off, the LED will get turned on, but the data is sent is 0, and the 0 data is visible here. Okay, so don't get confused. It's just the reverse data that we are sending. Whenever the switch is off, we are turning on the LED. When the switch is on, we are turning off the LED. Just reverse logic, nothing much complex here. But yeah, it is working. We are able to send and receive the data via MQTT as well. And you can attach a battery, attach a solar panel, make it as a standalone IoT device to run for forever. You can say it will charge with solar panel. It will run on battery. और क्या चाहिए यार. So that was all about the MQTT part as well. Now we are left with the GPS connectivity, and for GPS testing I need to go to the Windows side because the GPS do require some outdoor open sky to get connected with the satellite. Let me move to the different location. So here I moved to the Windows side and I placed the SIM7000G module just on the window so that it can have an open sky for getting connected with the satellites. And of course there are a couple of like vehicle noise coming in, so pardon me for that because I'm doing this for the testing purpose. Okay, so what I'll do is I'll straight away open the example code that comes along with the repository, which is GPS test. So I'll open with the Arduino IDE. So here is the code, and now here in the code we need to provide the APN name. I don't know why we need to provide the APN name here, but I provided the APN name www. After that, change the baud rate according to your board. I have set to 9600 only, and after that what this code will do is it will just print the latitude and longitude data separately on the serial monitor, which is awesome, right? So let's just select the right board and port which is already selected, and let me just hit the upload button. Now I have to wait for a couple of seconds to see the actual location at which I'm sitting right now. Okay, so the code is successfully uploaded. I'll open the serial monitor, I'll reset this board, and let's see what happens. So it says initializing the network test. Please make sure your GPS antenna is connected. Yes, the GPS antenna should be connected. It's a mandatory condition to get the location. Now we need to wait. Okay, so it started positioning and the blue light indicates the GPS status. So the blue light on the board will flash. Okay, so we got the location. So it says latitude is this and longitude is this, but we got only 2 digits after decimal, so this reveals that this is not the accurate location. While this is kind of an estimated location, you can say, we can't get a precise location with these numbers. Okay, so how to get the precise location, the question you may ask. Well, let me answer that question. Well, you just need to write one single line, which is modem.getGPS raw. Okay, so earlier we were writing modem.getGPS and latitude and longitude, but by typing the getGPS raw function, it will be giving us all the raw data of the GPS, and we can use that raw data for any of our project, any of our purpose, and in that raw data we'll be getting the accurate location as well. So let's just try to upload this sketch and let's see what results now we are getting. Okay, it says done uploading. I'll open the serial monitor. I'll once again reset the board and let's wait. Okay, so we got the data. So here's the latitude longitude data, and this is the raw data we got from the GPS module, and here is the latitude and the longitude data with precise location. Okay, so what I'll do, I'll copy this and let's just verify whether we are getting the perfect data or not. I'll open a new tab here and I'll open Google Maps and I'll paste the latitude and longitude data which I got. So I'll directly paste that. I'll press enter and let's see where it is. Okay, so it is pointing somewhere here, and so yeah, it is pointing somewhere here, and here is the TinyGSM studios. Okay, so this is the accuracy that we are getting. Of course, by moving it a little bit far away from this window, I'll get way more accurate results, you can say way more accurate position. So yeah, the GPS module is also working, and for our project what we can do is we can simply filter out these two data like the latitude longitude data and use it for our GPS tracking or GPS location based projects. Awesome, right? So yeah, that was all about the getting started video with the SIM7000G board. I hope you liked it, as I have covered almost all the aspects, all the different perspective or how to use this board, maybe for using with the MQTT broker, maybe using with the Blynk Cloud, maybe using for GPS connectivity, maybe using for sending and receiving SMS. I hope you find it useful, and I also want one favor from your side. So any of you watching this video, well, in your location, if there is an NB-IOT or LTE-M connectivity option, and if you have the access of SIM7000G model with you, well, do let me know, do that SIM card support on this board or not, or is there any changes about how to use those SIM cards on this model? Well, do let me know about using LTE-M and NB-IOT on the SIM7000G down in the comments of the video. The comment section is open for the conversation, and also share your thoughts about this board. Is it worth considering this board, or should we stick with the TinyGSM T-Call module that supports the 2G connectivities only? So do let me know your suggestion. Is 2G is good to go as of now, or should we upgrade to the 4G or NB-IOT? Share your thoughts down in the comments of the video, and also do share about what kind of project should I consider making using this particular board. Any of your project that comes in your mind, do share your thought about that project down in the comments of the video. And yeah, that being said, I'm just ending this video here and now. Just wait for my next video and then explore, learn, share with me, TinyGSM.